and let me know once you can see the screen.
Yep, I see it.
Thanks for the confirmation. So welcome to the Linux Basics live class. So this class is created for the very basic introduction to Linux, so that if you are completely new or if you are still starting into the Linux domain, then it will help you to speed up and also become comfortable with the Linux GUI and CLI, and also some of the important aspects, the base or the fundamental configurations which are required to go for the advanced stuff later, right? So let's start first of all with what exactly is the course structure, how we are going to go about in this course, and then we will see what specific topics we are going to cover. I mean, the broad structure, of course, we can include more things, or the specifics will come every week when we go into the details. So this course is going to be a live course on Zoom session once a week, and the sessions will be around 1.5 hour to 2 hours per session, depending on the topics. So it is basically the topic driven course instead of time driven. So some topics may take more time, some will take less time. But we are going to cover specific set of topics every week. And I'm also going to provide you the PDFs with the commands that are covered in that week, so that you will have the documentation of what exactly we covered. And of course, the recordings will also be available, right? This is an 8 weeks course, so we will have 8 sessions to get us started with the basics. But of course, this can be it can go to 9 weeks also, or more if we feel like we need to cover a few more things, right? But the base structure is to have the 2 months or 8 weeks course, right? So the main thing you will see about this is it's a hands-on approach course. So we are not just going to talk about Linux all the time. We are going to do a lots of hands-on right from the start. We will get to the CLI and GUI of the configuration, and we'll make sure that we get our hands dirty with the command line structure, so that we become comfortable with that. Because one thing you will notice, and we will discuss in this session as well, is that in Linux, mostly the CLI is preferred over GUI, especially if you're talking about the server side of operations. So if you are completely new to Linux and you just want to get familiar, of course, you can start from the client side or the desktop environments, like or desktop oriented operating systems with Fedora or Linux Mint or Pop OS. And that's a good start. But if you are thinking about going further as the system administrator and want to get into the depth of the fundamentals of the Linux server side configurations, then CLI is your friend, and we'll see what are the benefits and the drawbacks you have for the CLI. But yes, we will have a lot of CLI hands-on practicals and labs in this course. So for this one, the software, OS images, and lab instructions along with the solutions are provided. That means, of course, operating system images, it's Linux. So first of all, it is open source. So you can actually get them free, and you can download them from their respective websites. But I will give you a PDF also where I can mention some of the recommendations that you can start with if you already haven't done so, right? So you can't go wrong with any particular distro as far as the basics is concerned. But still, since we are going to be more leaning toward the Red Hat Enterprise Linux, so any variation of that will be a better choice, especially for the server side. Client side, to be honest, you can use any distro. That's absolutely not an issue. And this is going to be a live Zoom session, which are going to be recorded, and access to these recordings will be available on the course web portal. So one of the things that you will see is that it's a live course. So if you, due to some reason, you cannot join some week, don't worry. The recording will be available, and the recordings will be there for the lifetime access. So you don't need to worry that if you miss something, you can definitely go there, and the support will be there. So you can ask any questions on the Facebook group that you can join. And also, when you are watching the recording, there will be a comment section into the video itself, or below the video, where you can ask the questions, right? So this membership to Facebook community group is also provided, where you will see other students, not only just from Linux, but people who are learning CCNA, CCNP, CCIE, or AWS. So all students are there. So it's a good group where you can ask your questions as well, which can actually help you also to get the answer. And if somebody else is also wondering about the same questions, they can also get the answers from there. So somebody else has also joined. Let me see. Hey, hello, welcome. I see the name iPhone. So can you let me know who is this?
This is Walter Edmond. I'm able
Hey,
to get in
Walter.
there. All right. I had a
Okay.
hard time. I was on my website. I thought you clicked in through the website.
Okay. Okay. No problem. So welcome to the
Okay.
class, Walter. We have just
Thank
started.
Thank you.
So we were just discussing that today we are going to have just a basic introduction about the course structure and introduction to Linux and what exact information would you need to get started. So we will delve into the command line and to the configuration, installation, everything starting from next week. So this is just a small session to get you going with this course. And of course, the recording for this also will be available. So what we were discussing is that it's a course which is 8 weeks course and roughly 2 hours per session. We are going to have the hands-on approach and all the instructions that which OS images you can use will also be provided. I will show you exactly that what I recommend to use because we are actually leaning toward the Red Hat Enterprise Linux distros or any distros based on that. Because later you can actually move on to RHCSA and RHCE certifications, which are industry standard certifications to become system administration or become system administrator and get those system administration jobs or get the promotion that you are looking for uh, based on the Reddit links. But as far as the basics are concerned, you can't go wrong with any distro. You can also go with the Debian based or OpenSUSE as well, and it will be completely fine. One of the main thing you will see in this class is that you will get lifetime access to the recordings. That means if you miss a particular session due to any reason, or if you didn't miss and you want to just do a revision, want to go through the concept and everything again, you can watch the recordings on the portal after the class is finished. I think in a couple of days the recordings are uploaded there after the class, and you will also get the PDFs with all the commands that we have covered that particular week. So you will get the PDF document as well as the recording available for lifetime access. And anytime you have any questions, you can ask on the Facebook group, or when you are watching the recordings on the portal, there is a comment section there as well where you can ask your question, right? Hey, Michael, welcome to the class. So this is the course structure we have. Now, what exactly are we going to cover in this? So, as I mentioned earlier, is that this is the basics course where we want to get you started and become comfortable with the Linux operating system, especially with the CLI. Because if you want to go into the system administration direction, CLI is your friend. Of course, GUI is also important, especially if you are using it as a desktop computer. Then GUI becomes more important, and all the applications that we use on the client side become important. But if you're thinking about any services that you want to offer or want to manage, like you want to configure a web server or a database server or a file server, then server side mostly they actually use CLI. So many times they don't even install the desktop graphical user interface or GUI. And it's an option actually. You can decide to install it or you can skip it and directly use just the CLI, which can save you tons of resources, right? So in this course, we also have designed it in the same way so that we can become comfortable not only with the client side, but also the server side of configuration. So we will start with the introduction to the Linux, exactly what is Linux kernel, what are the different distros. Like today, we will discuss some of the distros, distributions, and the desktop environment, which is the graphical user interface that we use for this one. Then we will talk about the Linux operating system partitions and directories. So the folders in Linux are called directories, and there are different partitions you can use. And it's very important when you are installing Linux for the first time, or when you are practicing, you need to know that how exactly are the partitioning done. So nowadays, what happens is that they allow you to just let the system decide how many partition would be used and everything. but you can also decide how many partitions you will need, and we will see that which are the important partitions. Like boot partition is very important, and then you have your root partition, which contains everything, and your home directory. You may decide to keep these things into separate partitions, and also third party softwares maybe you want to keep into another partition, so you can create one more for the /opt for the optional directory. And what are these different directories that we use in Linux? So just to get familiar ourselves familiar with the directory structure. For example, the root directory, the /HC or etc, which contains the configurations, /var, which contains the variable files like logs. What exactly do we have into the home directory, /opt, opt directory, optional or third-party software. So all these things we will see, so that we become comfortable with the structure that Linux follows. And remember, in Linux, everything is a file, right? Or in any operating system which actually started from Unix, everything is a file. So when you install a software, basically you are installing some files into the /etc directory under subdirectories, and there are some variables and some libraries which are used by those packages. So we will understand those things. And then, of course, we will do the Linux installation. So Linux installation has become easier and easier over the years. And nowadays, mostly you will see a GUI interface there where you can select all the things to perform the Linux installation. And we will also see that there is an option to whether do we want to install GUI or we just want to keep it CLI. So mostly on the server side, if you skip GUI, that is completely fine, because most of the things you can manage from CLI. But if you are installing a desktop environment or desktop computer, like using as a daily driver, then it's better to install a GUI and use a operating system which can give you all these options like media codecs or third-party software support, and all these things become important on the client side. And then we will introduce the CLI and the basic command. So command line interface actually use a shell, and shell is basically the environment where you can execute commands, and you can start using your operating system according to your requirements. So the basic commands are very important, and not only we are going to cover it in one of the sessions, but also I'll provide you the PDF or Excel file where you will see all the important commands we have covered that particular week, so you can get that information stored with you, of course, along with the class, along with the recordings that we have. We'll also talk about the package manager and how do we install, upgrade, or delete packages. So you will see that that's where there are different distributions, because they depend on some of the different core distributions like Debian versus Red Hat, and they use slightly different package management system. So in Linux, when you install a software or a new service, that's called a package, because generally depending on the size of the software and the role of the software, there may be one or more files required for that to operate properly, and they package it into a single file, right? And that single file is called the package. And so many times they create multiple files like this. They are dependent on each other to work properly, and those are called dependencies. So if you're trying to install package A, but it depends on the package B and C to be already present, then installation of package A will fail if package B and C are not there. That's why Linux operating system or distros, they have some advanced package manager which can actually automatically resolve dependencies, and these are called the high level package managers. And then there are low level package managers also which do not resolve dependencies for you. So you need a higher level of knowledge and information that which dependencies will be required, and you have to install those first before installing the main package, right? So these things also we are going to learn. And again, what is important here is to understand that how exactly you interact with the package manager. And we are going to see both examples because there are two big distributions. You will see that one is Red Hat based, one is Debian based, and they use different package managers. And then there are very specialized Linux distributions where they might use a third type of package manager. But mostly you will see either it is the apt command, apt, or the yum or dnf command. So the apt command that we use, apt install or apt upgrade, apt delete, that is used by the Debian based Linux systems like Ubuntu or Linux Mint or Pop OS. or anything based on Red Hat, they use Yum or DNF. So Yum used to be the high level package manager for Linux, but they have recently changed it to DNF, which is just the keyword has changed. Most of the options and everything you will see are same in both cases. As a matter of fact, you can use Yum still, and then there is a symbolic link to the DNF command from there. So internally, it is going to execute DNF command for you to install the packages. We are also going to introduce to the Linux file system. Very important to understand exactly how the file system works. So you will see that there are different types of file systems. Like when you use Windows, we have FAT file system, FAT32, exFAT, or NTFS, right? In Linux, also you have many different options. You can use XFS or ext2, ext3, ext4, and many other options you have in the file system. And we'll see the basic differences between these, that how exactly one is different from another, and which one should you choose for your server side or client side, or should you allow just the system to decide it for you. So irrespective of which file system you choose, you will see that most of the advanced file systems, they support very huge file sizes, and they are fairly advanced in correcting the errors into your files or in your partitions. So it's not actually a big deal which one you choose. Mostly ext4 or XFS are the file systems which are used. BTFRS used to be very useful, but especially in Red Hat Enterprise Linux, they have stopped supporting it recently. But again, ext4 or XFS will be more than enough. So we are going to understand all these keywords. Don't worry about it right now. That what exactly do they mean if you are not familiar with this, because we are going to understand them properly when it comes to the file system. Then comes the users and group. So this is another very important thing, especially if you are using it into a network environment where multiple users may access the files and the resources that you have on on your Linux system or on your server. So it becomes important that you decide the authentication, which means verifying the identity, and the authorization, which means deciding that what level of access the particular user will get. So authentication and authorization can be done if you know who is trying to access the resources, right? So that's why creating user accounts are very important. And so many times, if you have shared resources which multiple users want to use them, then it's better to create group of users so that you can decide the authorization, means what level of access they will get by associating the authorization rules to the group. And any user who is member of that group will get the same level of authorization. For example, if there is a file that you want that some user should only be able to read, then you can associate the read permission with the group and make all those users a member of that group. Then another set of users, they need to modify the files, read and write access they need. So you can make them the member of another group, which can have the read and write permissions associated with it, right? So creating user accounts, group accounts, managing them, we will see, including the root user account. So in Linux, you will see root is the all-powerful user who can do everything. And we always say like root level access you have. That means you are you can do everything into that system, and nobody will stop you. Even you can decide to delete the whole root partition or delete all the files. Linux might give you a warning, but it doesn't stop you from doing any of those things. So that's why generally we do not use the root user for our day-to-day tasks. Instead, we use the local user account. And then whenever we need to perform something which needs elevated privileges, we actually use the command sudo, which means switch user and do. And what we want to do is some kind of higher level privilege configuration or commands. Then it is going to execute those commands with the root level access, and then it will come back to your user level access. So it becomes easier to control what can be done. And also, if somebody is trying to attack your system and somehow they gain the access to your system using the user credentials, then they will not be able to directly do anything because they do not have the same level access of the root user. So these kind of best practices also we are going to learn in this course. Then we are going to discuss also about the file and directory permissions, as I mentioned earlier, that when you create the user accounts and the group accounts, then you can associate different level of permissions for the different users and groups. So we will see how we can control that. And again, as I mentioned earlier, just to reiterate, whatever we are going to cover into that particular week, it will be recorded. and the recordings will be available to you guys for the lifetime access. So you don't need to worry. You can always go back to the recordings for revision, or if you miss the class. And also, I'll provide you the PDF with the important commands so that you know what commands are covered in that particular week, right? We are also going to talk about the editors. So there are so many editors in Linux, and most of the times what people use, power users, they use VI, which is slightly difficult. It has a learning curve. But once you become proficient in VI, you actually prefer, administrators actually prefer to use VI over any other editor. It's very raw, and it's all completely CLI command based. You need to remember different commands to even copy, paste, or cut, or do any kind of file operation. But of course, there is a simpler version also, which is called Nano, where you will see that although it is also CLI based, but it's simpler than VI. There are other editors also, Emacs and all, but mostly Nano and VI is what you need to remember, what you need to know for the basics part, right? And of course, we are going to learn the networking basics. So that we can connect to Linux servers. So we are going to understand what exactly networking is, enabling communication, what is IP addressing, how we can configure IP addresses on the interfaces of Linux operating system device, and how we can manage it. So NMCLI command, NMTUI command, whether you want to use it from the CLI or graphical interface, and how we can connect devices. And then we will see some operations that you can perform in networking. For example, when you connect two devices, how do we copy content between these two devices? How do we access one device from another one, like remote access using a secure shell? So these kind of basic networking tasks also we are going to learn. Again, the objective of this course is to make sure that you become comfortable with the installation of the Linux and the basic setup of the Linux, and then getting to the file system, permissions, and networking, right? That's the core part. So once you are good with that, then you can actually go to the next level. You can go for the RHCSA certification path, then RHCE later. Or if you decide to go any other distro not Red Hat, that will also be completely fine, because the core commands are same no matter which distribution you're using. And we'll also do one project at the end, which is configuring a Linux web server using Apache web server. So Apache is one of the web services that you can install to make your server a web server. So if you have a web page that can be accessed from the browser using the IP address of the server. Another option is using Nginx. Nginx is another web service, so you can use that one as well. But of course, the configuration files will be slightly different. The locations will be slightly different. But we are going to do this project as well, right? So if the networking is there, you will be able to open the web page from the client operating system, and you will be able to see whether it is working or not. And we'll see if you have to do it for HTTP or HTTPS. So you'll see in HTTPS, we need to create a certificate as well. The SSH or OpenSSL has to be installed. So what options will we need to configure for that part? So we'll do a small project at the end, right? So that's what we will cover in this course. And what tools are we going to use? So we are going to use VMware Workstation Player. So if you guys have received the email already, let me know. Or if you haven't received, let me know as well, so that I can send you, where I had shared the link, download the VMware Workstation. And this is just the virtualization software. So if you decide to use the VirtualBox instead of VMware, that is also fine. And we recommend to use the Windows operating system, because if you are using Windows or Linux, so if you are already using Linux, that means you are good in Linux anyway. But if you're using Windows operating system, then VMware Workstation works slightly better than VirtualBox, or slightly faster than VirtualBox. But to be honest, you can't go wrong with any of these, because we are just going to install the operating system here, right? And the individual Linux OS files will be installed directly in the VMware. So we are going to use one server and one client, right? So that we can do the networking and the project as well at the end. So most of the basic commands and for file system partitioning, installation, creating user accounts and group accounts, and all these things you can do on a single device as well. You don't need two devices for that. But for networking and connectivity using networking protocols like SSH, or using our web server project, we will need at least two devices, one server and one client. So you can directly install these using their ISO files into VMware Workstation. And the VMware network type you can keep as NAT. So what happens with this is that it will allow you to enable communication between the two different Linux installations that you have done. And you can also use the same option to communicate with the host machine. So let's say I'm using my Windows 11 desktop here, and I have installed Red Hat Enterprise Linux and also Fedora client or Linux Mint, and I want to enable communication between these three clients. Then I want them to communicate with my Windows 11 host as well. So by using the NAT type of network, which is the default when you are configuring any or installing any new operating system in VMware, they will be able to communicate with each other. So we are going to create a small network of devices, interconnected devices, right? Which can help us in the networking practicals when it comes to that part. So for most part of the course, as I mentioned, only one Linux machine would be enough because you are just going through the basic commands. But when it comes to networking, that time we will need more than one. We will need exactly server and client to be specific, right? And although VMware is recommended, as I mentioned, but if you decide to use VirtualBox, then the bridge mode would be better, because in the bridge mode, all the devices which are using that mode will be able to inherently communicate, and they will also be able to communicate with the host machine. And by the way, if you are using VMware Net mode or the VirtualBox bridge mode for the network interface, you will also be able to access internet right from inside your Linux machine to update the packages or install new packages. The internet connection can be very helpful. So get it directly from the online repository, right? So for example, if you go to the virtual machine settings in VMware, uh, two important things to remember here. One is the network adapter. So as I mentioned, it has to be NAT, network address translation, and the RAM. How much RAM do you want to assign to the device, right? So in Linux, if you're using a server, even 2 gig RAM is enough, because mostly we will be dealing with CLI. But I would recommend to use 4 gig. If you have a 8 gig laptop, you can actually give 4 gig to the server and 2 gig to the client. That will be completely fine. Or you can use 2 gig on both of them. So Linux is not so much resource heavy, especially when it comes to CLI. If you are trying to use more advanced graphical user interface settings or options, then you might need more memory to get a more streamlined performance there. So I was mentioning that you just need to make sure that you have the proper net configuration mentioned here. So let me just give you an example. If we go to the VMware Workstation player, here you will see that, for example, if I go to one of the installation like Red Hat Enterprise Linux 9, and you click on the edit virtual machine, here you will be able to see these options here, like how much RAM do you want to give, uh, and what network adapter do you want to use. So the net is the default adapter anyway, but in case if you see something else here, just make sure you change it to the network address translation option, right? All right, I see a question from Todd. Is VMware Pro okay, or does it need to be the player? No, Pro is okay as well. So if you have VMware Pro or Workstation Pro, that is also perfectly fine. You just need a proper VM host. So VMware Player is the free version, in case if you don't want to pay for it. But I think the Pro version is the paid version. That is also perfectly fine. And VirtualBox is also free. So you have all these different options, right? All right, so let's introduce Linux a little bit today. So as I mentioned, today we are just going to keep it basic. So you will have this whole week to set up your VMware and install the operating system images. By the way, I will send you one more document today. Let me show you that. So I'm going to send you one PDF document which has the links to download the Linux operating system. Now, of course, this is freely available on internet. You don't need a document for this. But the reason I have created this, just to let you know that there are two different types of distributions, Debian based and Red Hat based, and we have decided to go with the the Red Hat based implementation, right? So what it means is that we will need to choose at least one server side operating system and one client side, and you can decide which one you want to use. So for the server side, you can use either RHEL 9, which is the official Red Hat Enterprise Linux operating system from Red Hat. And this one needs you to actually register, and you can go to the developer website where you can use it for free. So although it is a paid software, paid means it's open source free, but the support is paid. You need to pay for the support, especially if you're using in the enterprise environment. But if you just want to do it for practice or your own purposes, then you can go to the developers.redhat.com where you can create an account, and then you can use up to 16 Linux servers for free. You don't need to pay anything for that, right? So the only thing is that you need to register your operating system with the subscription manager register command uh, once you have installed it. So if you don't want to go through that hassle, you can actually use the Rocky Linux, which is actually bug for bug 100% replica of RHEL 9, right? So generally we call them the downstream implementation. Downstream means that once the RHEL 9 is released, a new version is released, you will see the exactly same replica is created by these variations. Like there used to be CentOS like this before downstream, which is like the exact replica of RHEL 9 or any RHEL server. But CentOS has been decommissioned by Reddit, and now it has been created as a CentOS stream, which is now the upstream server. That means it is used first to check the features and everything, and then you create RHEL based on the feedback and based on the performance of those features, right? So it is no longer the downstream server. So Rocky Linux is actually very good because their website says it is designed to be 100% bug for bug compatible with RHEL. So basically, it is an exact replica of Red Hat Enterprise Linux without any registration headache, right? So that can be a very good option. Or you can go with Alma Linux, which is also the downstream of RHEL 9. So because we will be concentrating on the Red Hat Enterprise Linux server-side configuration, on the basic level, again, there is no difference. But when it comes to like package management and everything, we will go with the RHEL 9 path. So it's better if you use one of these three servers. So you can decide which one you want to use. But having said that, even if you're using a Debian-based server, you will see, especially this basics course, there will not be much difference, right? You don't need to worry about too much about that part. But later, when you go for advanced stuff, like if you have joined our 0 to Linux 52 weeks program, that is actually aimed for RHCSA and RHCE certification. So there, of course, you need to use one of these three as a server, right? And for the client side, to be honest, you can use any client operating system, that is perfectly fine. But we recommend you can use either Fedora or Linux Mint. So Fedora is actually open source desktop client, which is Red Hat based. So this one is used as a test bed for checking new features and things for the RHEL enterprise server, right? So whatever you see in Fedora, it might be included later in CentOS stream, and then finally into the official RHEL Red Hat Enterprise Linux server. But it has a good graphical user interface, and of course, the command structure and the package management, everything is same as Red Hat Enterprise Linux or RHEL. So it could be a good client if you want to keep the command structure exactly same. But if you want to learn both sides, like Debian based command structure as well and Red Hat based as well, so the client you can decide to use as Linux Mint or Pop OS is also good. Both are Ubuntu based, which itself is based on the Debian Linux, right? So you can decide which one you want to use. So I've just given you some links. Of course, you can find them directly also on Google. But just to give you a recommendation, what we are using, right? So coming back to the Linux, let's introduce Linux, basic Linux today. So we are not going to get into the command line structure or any configuration today, just the basic introduction. And then of course, you will have 1 week time to set up everything. And then we can start with the practicals from next week, right? So Linux is a family of free and open source operating systems, like based on one thing, which is common between all of them, is Linux kernel. So kernel is the core part of an operating system, which directly deals with the hardware and deals with the high level software. And it's like a middle level or the low level agent, which is managing your complete infrastructure of your computer. So operating systems which are based on Linux are known as the Linux distribution or distros. So why they are called distros? Because the kernel is same. They all are using Linux kernel, but of course the desktop environment and the higher level softwares which are going to deal with the Linux kernel, they are slightly different into each one of them. That's why there are literally hundreds of distros out there. I think close to 1,000 distros are there that you can choose from, right? But the kernel itself is the same as far as it is a Linux distribution. So you will see that it was initially released by Linus Torvalds on September 17, 1991. So, the mother of all the operating system is Unix. Unix was the first operating system, you can call it a proper operating system, but that was not free. And huge organizations like IBM or HP, and these organizations, they actually created their own version of Unix by changing few things and made them proprietary. So it was not free, and that's where there was different projects like GNU project was started to make it open source or something that is similar to an open source project. But the GNU had an issue that they did not have a proper kernel and it wasn't created yet. And by the time Linus Torvald has created something called a Linux kernel, which was open source and free, and using the GNU license, which is the license to use uh, and modify. So it is called GPL or GNU General Public License, which was used. And the source code can be modified and distributed to anyone commercially or non-commercially. So that actually changed the game for the operating systems because until then, of course, GNU was trying to create its own kernel, but they were not so successful by that time. And Unix was not the free software or not the free operating system. Of course, Microsoft and Apple was also not free. So this actually changed the game for them. So initially, it was created for personal computers. So Linus Torvalds was thinking we can create a free operating system anybody can download and use on their PCs. But of course, it later it is used into the servers, mainframes, computers or supercomputers, etc. Right? So as a matter of fact, you will see that nowadays Linux is also used into the routers, automation, controls, televisions, digital video recorders, video game consoles, and smartwatches. And one of the biggest success of Linux is the Android operating system. So if you're using an Android phone, you are actually using Linux on your phone because Android is completely created over Linux operating system. So if we see the timeline, Unix was created in 1969 in Bell Labs, and then, of course, Microsoft created MS-DOS in 1981 with a very close kernel. So it's restrictive. You cannot reproduce it. You cannot modify it. You cannot resell it. Apple created Apple System 1 in 1984. So until then, there was no free operating system that you can freely distribute or modify. And that's what changed in 1991 when Linux was released, right? And Mac OS was actually based on BSD, which is another form of Linux, but it's a different kernel basically. So it's not Linux kernel. So you can say another form of Unix, sorry, not another form of Linux. So Mac OS is also based on Unix kind of operating system, which came in 2001, right? So talking about the Linux server, you will see that throughout the world, Linux servers are very popular because they are very stable and highly secure. So they are mostly used as web servers, name resolution. That means you want to use the name instead of IP addresses. So we need a domain naming system service which can change the name to IPs. File storage, print server, log servers to centralize and store log files from other systems so that you know what event happened at what time with the timestamps and everything. Virtualization and container, that is becoming very popular as well. So to host the virtual machines or container virtualization software. So what is the difference between virtual machine and container? So virtual machine is when you are installing the complete operating system in a separate space. Like for example, I'm using VMware to install either EVNG, which is a Linux machine, or I can install Windows machine there as well, or any operating system which is contained within its own environment, right? Container, on the other hand, is just creating an application and all of its dependencies packaged into one container, which can be executed on many operating systems. So you don't need to worry about whether this file will run on another computer or not because it has some dependencies. All dependencies and the application itself is contained within this small virtual entity, which is called container. So these servers are also supported in Linux. A database server whether it is SQL or no SQL databases, they are also supported in Linux server. And you can use it as a cluster as well, which means that you can host the same application on multiple devices which are working together for fault tolerance and to divide the load, right? To share the load. So we have been talking about this, about Linux distribution. I have been using the keyword distro. So if you're not familiar with this, as I mentioned earlier, it is just like the upper layer on the Linux kernel, which can be different, how you present it and how you use it. So you will see that it is the Linux distribution is actually the package which contains the Linux kernel and also contains the outer layer of the operating system, with like the desktop environment, graphical user interface, package management, and all high level things, right? So it's an operating system basically that is made up of a collection of softwares based on the Linux kernel, right? Because remember, Linux kernel itself is not an independent operating system. You can't use it directly. You need an upper layer for this, which we call shell, and the desktop environment, right? So you can also say that Linux distribution contains the kernel and the supporting libraries and software. What is the difference between the libraries and software? So basically, the software is the main component which is solving a particular issue. Like you want to have web services, so there is a software called Apache or Nginx. But then they might need some extra functions which are common with other softwares as well. So let's say if a particular function is common between many softwares, so instead of keeping a separate copy of that function for every software, we can create a library. Library is basically that particular part of the function which is needed by all the softwares, and they can access this library anytime they want to execute that function. So you don't need to keep the copy multiple times. So if you guys are familiar with programming, or if you have ever done programming before, you know we use the functions in programming to execute a part of the code again and again, right? So we can just call that function and that part of the code will be executed again. So you don't need to copy it again and again, the whole thing. So if the whole operation takes 10 lines of code, you don't need to type 10 lines of code every time you want to do that. Like, for example, if I want to find out the square root of a number, and I have created a code of 10 lines to find it out. So if I want to take a square root many times in my program, in my code, I can just call that function, which has that 8 to 10 lines. So I don't need to copy it again and again. So function works like that inside the programming language, right? In software, they might need some certain dependencies or some certain part of the function, which we call libraries. So libraries are basically the common piece of software, common piece of coding, which may be required by multiple softwares, right? So that's the basic difference there. And how many different types of distributions do we have? You will see that there are some core distributions. For example, Red Hat and Debian. These are two of the oldest distributions. Like Debian started in 1993 and Red Hat started in 1994. And these are the core distributions. And other distributions that you see, hundreds and thousands of distributions, they are actually based on either Red Hat or Debian or BSD, which was before Linux, right? The Berkeley system distribution, software distribution. But there are specialized distros as well, which are created for a specific task in mind. For example, there is a distro called Zorin OS, which wants to look and feel like Windows. So if you are coming from Windows operating system, you can use Zorin OS so that it is completely like Windows. Even it actually has a support for the software which can execute the the Microsoft.exe and MSI files directly on the Linux. So you can execute Microsoft programs on Linux operating system, and it looks and feels like Windows. So if you're coming from Windows operating system, you will not actually feel completely different or foreign if you're using Zorin OS. Or, for example, Gentoo Linux, which actually is created for developers and programmers. So it's a very high level of Linux where nothing is compiled. You need to compile everything on your local machine, right? So there are different types of distros like this as well. And there are some live CD distros as well. Means you can directly run them from the CD or the DVD where you burn the operating system ISO, and you don't need to install this on your hard disk drive at all. You can always use it from the live CD as well. So the main use case of this one is to try it. For example, if you want to try Linux Mint before installing it on your system, you can burn it to a DVD or a CD, and then you can directly use it from the CD, boot it from the CD or a USB, and use it for some time, and if you like it, then you can decide to install this on the hard disk drive, right? But having said that, what are some of the major distributions that we have of different types? So you will see that if you want to start using Linux, and if you are an end user currently, you are not looking for learning the server side stuff yet, just to get yourself familiarized with the basics, you can go with the easiest ones like Ubuntu, Linux Mint, MX Linux, or Zorin OS, as I mentioned, or Pop OS. These are some of the options which are easier to start with, right? Even if you are completely new to Linux operating system. On the other hand, if you are on the advanced side, you can go with Arch Linux, again, too, or Slackware Linux, which are advanced distributions which need comprehensive knowledge of Linux before they can be used effectively. Because you need to build everything up from the scratch, and they don't have any high level of package management directly used. They use low level package management where you need to resolve the dependencies manually and those kind of things. Slackware, especially, is not even based on Linux, it is based on BSD, and Gentoo, as I mentioned earlier, it actually compiles everything locally on the device. So this one needs advanced level of knowledge. There is a funny thing also. Many times people say that if you hate your life, you should use Arch Linux, because if there is any issue, you will go into the rabbit hole of trying to solve it. But of course, that is going to make you extremely proficient in Linux if you are dealing with these kind of issues every day, right? So that can be a good idea to do once you finish this Zero to Linux course. Not the basic course, but the 52 weeks course we have. Once you get familiar with the server side things also, then you can decide to go with that. And then, of course, we have the middle ground as well. You can use OpenSUSE, Fedora, RHEL, or Debian, which are considered mid-level distros. So they do have their GUI, and they allow you to install packages right from the installation time. You can select what exactly do you need, but they are not as user-friendly as the Linux Mint or MX Linux or Pop OS, these kind of things, right? So talking a little bit more details about these distros. So the core one, as I mentioned, one of the oldest distribution based on Linux kernel is Debian Linux. So it was developed in 1993 by over 1,000 volunteer developers, and it contains close to 50,000 binary packages. So it's a huge collection of packages that you can use, and it is keep on increasing. So it is inspired more than 100 Debian-based Linux distributions and live series. For example, Ubuntu is also Debian-based, and there are so many other operating systems which are based on the Debian Linux distribution. There are three main branches. So if you decide to use Debian, you can use the unstable version, testing version, or the stable version. Right? It is similar to in Red Hat you have Fedora, and then CentOS is Stream, and then Red Hat Enterprise Linux. So Fedora is like the test bed for all the new kind of things. Everyone can create their own softwares, their packages. They can try it on Fedora. Similarly, in Debian, you can do all these things into the SID branch, which is the unstable branch. And then more of the stable ones go to the testing phase. And once they are thoroughly tested, they can be released into the stable cycle, which can be used as an enterprise server in your organization. And you don't need to worry about any unexpected behavior because this is thoroughly tested and bug free, basically, right? It is very stable, and you get high level of quality control in Debian, and it supports more processor architectures than any other Linux distribution. So that can be another deciding factor if you want to use Debian. The only thing is that the newer technologies are not always included, and it does have a slow release cycle, right? Because people are not as excited about Debian as they are about Ubuntu, which is based on Debian, or for RHEL, for example. Another one is Fedora, which is actually introduced in 2004, but formally it was known as Red Hat Linux. And origin actually dates back to 1995. See, 1993 Debian started, and 1995 Red Hat started. And Red Hat started a different branch of package management using RPM. So it introduced the revolutionary RPM package management with dependency resolution and other advanced features, and it is highly innovative. So they keep on they become the industry leader in innovating new things, allowing people to use Fedora for practicing or testing whatever they want, or create their own operating system based on the core of Fedora. uh, it has outstanding security features. It has been industry leader in that as well. and the large number of supported packages. The thing is that it tends towards the enterprise feature more, although people say Fedora is the desktop side like Linux Mint, but it's not so user friendly as Linux Mint or Pop OS. The reason is because it is used as the test bed, right, for the features that would be included into the server, a Red Hat Enterprise Linux server later, right, rather than just the desktop usability. On the other hand, if you want to use the proper server side operating system, where you have all the stable features tested in Fedora and then in CentOS Stream, then you can use Red Hat Enterprise Linux. So it is a downstream distribution of Fedora and CentOS Stream. This one is commercially backed and supported. Means if you are using RHEL, you can purchase the support plan. So if you have any issues, especially if you're using in your organization, in your enterprise enterprise capacity, then you don't want to wait for the try and test method, right? Something is happening, you want to fix it as soon as possible. So you can depend on the experts in the Red Hat organization to help you with the support there, right? And support is generally for 10 years or more. So it's actually very stable if you are deciding to use it. That's why RHEL is very, very popular in industry as the server side solution. And if you have the RHEL based certifications like RHCE or RHCE, they are actually regarded on very high level, highly coveted certifications, and can actually help you to get that system administration job or that promotion that you're looking for. A free developer license, as I mentioned, is available for testing and for small home office implementation, because you can have up to 16 RHEL servers running without paying anything and without getting any commercial support or without using any commercial support. So this is what I was talking about into that PDF file, right? That you can install RHEL, but you just need to register it. Even if it is free, it has to be registered before you can start installing the packages. So for package management, it uses DNF. So earlier it used to be called yum, but now it is called DNF. And the command starts with the keyword DNF. DNF install, DNF update, DNF remove, to install or update or modify or remove the packages or the softwares basically. Another one is OpenSUSE. Although OpenSUSE also depends on RPM, so you can call it from the Red Hat branch, but generally they consider themselves separate because it was actually very old. This was created back in 1992. So even before the Red Hat was there. So many people actually consider this one as the third branch of the core Linux distros, right? So it is created by four German Linux enthusiasts, and it has two main editions, Leap and Tumbleweed. So the Leap is the operating system or the edition which gets the periodic releases of the new version of the software, right? On the other hand, Tumbleweed gets the rolling release. Rolling release means the new updates are keep on updated on the system without coming up with the new version every time, like 9.2, 9.4, 10. They don't do like that. They just keep on updating your system every time there is something new. Leap, on the other hand, comes in distinct versions, and the new version will have more updates, stable updates than the older version. So server side, if you're using it in the enterprise environment, the Leap is the better one because it is stable one. And Tumbleweed is good for practice and exploration because it keeps on getting updated. So some updates might not be stable. So it's not a good idea to use it in the enterprise environment, right? The benefits of OpenSUSE is it is comprehensive and intuitive configuration tools, large repo of software packages, excellent documentation, and it uses the RPM package manager, right? The only issue with OpenSUSE is sometimes it is considered bloated and slow as it has resource heavy desktop setup, right? But nowadays, computers are very strong. It's not like 20 years ago, so it's fine. You can use OpenSUSE as well. Another one is FreeBSD. That is actually one of the distro, which is, to be honest, is not a Linux distro because it is not based on the Linux kernel. It is based on the BSD kernel, basically, Berkeley Software Distribution. And it is actually tightly integrated OS built from a BSD kernel, fast, high performance, and extremely stable operating system. But you see that it's not so much popular when you think about Linux because it is not Linux. It is not based on the Linux kernel. So technically, I should not even call it Linux distro. It's basically a Unix-like distro, you can call it. So this one is actually very stable. So it is suitable for web servers and search engines where you need high availability. And you see that many of the web servers and search engines are actually based on FreeBSD. And because it is based on BSD, it is even much less restrictive license comparing to Linux. Linux uses the GNU GPL license, but in this one, it has even less restrictive licensing than that. And it uses the concept of ports, more than 24,000 software applications. So instead of calling them packages, it is called ports. Different ports are used here, and it has very good documentation. And actually, you can find out any issues can be fixed by going through the documentation, right? The issue with the Linux, this BSD distro is it lags behind Linux in terms of support of new hardware. So it's not very fast in adapting to new technologies or new hardware. And limited availability of commercial applications and a lack of any GUI tools actually makes it not so popular for the new learners, basically. Some others which are on the client side mostly is Linux Mint. It is based on Ubuntu. It has a good collection of tools developed in-house and support for features and multimedia codecs. This is very important because multimedia codecs are individual softwares, right? They are proprietary softwares. So so many Linux implementations they do not support all the multimedia codecs, but Linux Mint does. So if you're going to use it for playing videos or any kind of graphical work or gaming, then Linux Mint can be very useful. But even better would be Pop OS, to be honest. Pop OS is also Ubuntu based, and it supports NVIDIA graphics drivers more natively comparing to Linux Mint. So if you are planning about gaming, Pop OS will be a better choice. But Linux Mint has a huge support as well, open to user suggestions and used widely everywhere. But it doesn't issue any security advisories, right? So it's not maintained that well. It is based on Ubuntu, so of course, let's talk about Ubuntu. So that is actually Debian based, the unstable branch of Debian, where you can try and test everything, and new things can be included. There are some fixed release cycle and support period. You will see that non-long-term support and long-term support. There are two different types you can use. Long-term support, Ubuntu is more stable, basically. The best thing about Ubuntu is that it has extensive documentation online, both official and user contributed. I would say the number one distribution which will you will see on internet as far as support is concerned. You have any issue with Ubuntu, you go and type it on internet on search engine. You will find more than 10 documents explaining how you can fix that. So you can see Ubuntu is extremely popular in among people. So although it is Debian based, but it lacks compatibility with Debian because it is using the unstable branch of the Debian Linux, right? Other ones that you can use on the client side are MX Linux, which is also Debian based, but it's from the stable branch. And it is the result of merging of Mapis Linux and the Entix, and they created MX Linux with that. The benefit with MX is that it has the out-of-the-box support, so graphic drivers, browser plugin, and media codecs, right? Stable core with updated desktop application. So this can also be a good client-side Linux that if you want to use, because it supports the codecs and everything as well. Another one is Arch Linux. As I mentioned earlier, this one is for advanced users because it doesn't actually compile everything, or it doesn't give you a very high level of package management. And it uses rolling release model. Rolling release simply means that there will not be a new version after some time which you can update from your current version. Instead, the new updates are keep on sent, and your system will keep on updating incrementally every few days, and that is called the rolling release model, right? And the package manager is called Pacman. It is one of the benefits of Arch Linux is it is highly customizable. That's why you need the advanced level of knowledge for this one. And there is occasional instability because of the rolling release. If something new comes up which can disturb your current environment, and there is a risk of breakdown also. So many times people say that every month or every couple of months they need to recreate their Arch Linux because it gets broken down because of something which was sent into the new release or some new update. Another one is Gentoo Linux, which is basically geared towards developers and networking professionals. And typically, this is set up with the bare minimum set of pre-compiled packages and everything else is actually compiled right on your system. And the package manager it uses is called Portage, which is Python based, which supports many advanced features. Right. Again, this one is also highly customizable, very flexible, and able to use a range of compile time configurations in its systems, and can actually run on many architectures. So this is a very good candidate for the advanced professionals. So once you get to that level where you are comfortable with Linux, you have done your RHCE at least, then you can actually start delving into Linux to get more insights, or Arch Linux to get more insights of your Linux operating system curve. Slackware is another one, which is again highly stable, clean, and mostly bug free. But the problem is that there is limited number of applications and a complex upgrade procedure. But this is also one of the oldest implementation of Linux distros, right? So at the end, as I mentioned earlier, I will according to the PDF I showed you earlier, we are going to go with either Red Hat Enterprise Linux or the Rocky Linux, and you will see that they both are have the same look and feel. The command structure is exactly same, so you can't go wrong with any one of them. The only thing is that if you use Rocky Linux, you don't need to register it anywhere. You can directly start using it right after installation. Red Hat Enterprise Linux, you need to make an account on the link I had provided in the PDF, and then you have to register your system there, right? So irrespective of which distribution you use, what are some of the pros and cons of using Linux? So the advantages of using Linux is, first of all, it is open source. It is securer than other operating systems, mainly because in Linux you have the concept of blocking everything, and then you can gradually start opening the ports and the services that you need to use. And of course, you can use security enhanced Linux or SE Linux to make it securer. Inbuilt firewall is also there, and the software updates in Linux are easy and frequent. So anytime there is a security breach or any issue, they can immediately push new security updates that can help you to mitigate those issues, right? And various distros are available so that you can use them according to your requirements, right? Depending on your taste, there are literally hundreds of distros there. There is a website also, distro watch or watchdistro.com, something like this, where you can see which distros are in trend, which one is number one in popularity, which is number 100, and how many different distros are there. And it has a large community support. Linux is nothing without the community, because it is open source. People use it freely, and they actually have their opinions and their suggestions and their solutions for all the different kind of problems. So if you are starting using Linux and you come up with any issue, you can be 100% assured that somebody else also already had this issue and they have discussed about this on internet. So you can find the solution for sure, right? That's why it's highly stable, and just compatible with a large number of file formats. Even FAT32 and NTFS are supported as the partition types, file types. You can use them. So compatible with Windows. Fast and easy to install from the web. It can also install on any hardware. Even if you have an old computer system, you can specifically use special like Lubuntu, which is the lightweight Ubuntu, which doesn't take much resources. So there are distros which can be used even in the older computers as well. This advantage you can see is that it is not very user friendly, although this is also changing slowly. If you're using Linux Mint, Pop OS, these kind of or Zorin OS, these kind of fleshy operating systems, then they are very easy for beginners. And it has a small peripheral hardware driver as compared to Windows. So compared to Windows, yes, it is smaller, but that is also, this gap is also bridging very fast, right? All right. So next thing is that when we talk about a particular distribution, what are the different components? So this is something we already discussed. There is a kernel, which is directly in charge of the hardware, controls all the important hardware in the system. And then you have D, or desktop environment. So desktop environment is the front shell for the user experience, and it decides the overall visible layout of your operating system. So that's your GUI basically. And examples are, you can use Genome, Cinnamon, Met, Pantheon, Enlightenment, KDE, or XFCE. These are only some examples. Again, there could be so many different desktop environments depending on what exactly do you like. But the most popular ones are Genome or KDE on the server side, or XFCE, and Cinnamon or Genome on the client side, right? So every D or desktop environment actually has pre-installed programs like file manager, configuration tools, web browsers, games, So anything has to do with the graphical user interface. So for example, the genome is the most used, the GNU network object model environment. And this one is actually very stable. It gets regular updates. Active community, one of the oldest one, and lots of app support is there. Same thing with KDE or K desktop environment or KDE Plasma, which is lightweight, easy to use, highly customizable, and there is an active community there as well. Super fast and visually appealing as well, right? So to be honest, you can't go wrong which one you want to use. It's all about the personal taste, right? Which one is better for you? Another one is Mate, which is the lightweight D or desktop environment. So if you are using an older system which doesn't have much RAM or much processing power, it's better to use Mate because a Mate will actually give you some option to use less resources. It's resource efficient. Great for servers, basically, that's why. Time tested, it's actually also an older one and supports a full set of applications. So there is no compromise on the number of applications that you can use. XFCE, on the other hand, is also lightweight, stable, user friendly, and the only difference is that it has less modern graphics compared to Mac. So you can decide which one you want to use there. But enough of the GUI part. Let's talk about the CLI. What exactly do we mean by CLI or command line interface? So you will see that Linux administrators prefer CLI for most of the tasks as it provides many benefits, like it is quicker. So if you know the command line, you will see that the graphical user interface will always be slower because that is another layer of configuration before the commands can go to the kernel. CLI directly can send the commands to the kernel. Consumes fewer hardware resources. Of course, the GUI will take more resources compared to CLI. And the biggest thing is it is scriptable. So you can actually create a simple text file with all the instructions, and you can execute that text file as a script, and all the instructions will be executed immediately. It can make your CLI even faster, right? But of course, there are some disadvantages of CLI also. First of all, of course, the biggest one is the learning curve. Like when you open a GUI, like a graphical environment, you have so many things to explore. But when the CLI is open, it's a blank screen. It's a black screen with a cursor blinking, and you need to know what you want to do before you can do anything. So there's a learning curve there. It's non-intuitive. So it actually, the commands, sometimes the options that we use in the command do not directly make any sense. They have some meaning that you just need to remember. And that's why there could be syntax mistakes there. There are some things you can do. You can keep on practicing. You have some documentation and help. You can use context sensitive help is there. Command completion is there. But of course, it needs practice to become comfortable with CLI. And CLI is actually commands. So where do you type these commands? You type this command in something called shell or command shell, right? So common command shells supported in Linux are bash, KSH, or Korn shell used by Unix originally, or Z shell, which is still used by Mac OS, right? So talking about Linux shell, the CLI is provided by the software called a shell. So just like desktop environment is the graphical user interface software, shell is the CLI software, right? Providing you the CLI. So the concept is that it accepts the user input, processes the input for syntax, and provides the output back to the user, right? So the default shell for most of the Linux distribution is bash and a born again shell basically. So that's what will be installed when you install Linux, but you can install other shells as well. Although for the basic level, you don't need to. And the syntax for any bash will be, it will expect a command from you, the primary instruction given to the system, and then it will expect some sub command, a secondary, more detailed instruction supporting the primary command, and then you can have some option. So the options are actually a command modifier that slightly changes the way a command is processed, right? For example, if I use the command ls command is used to list the content of the directory. But I don't want to see the content into horizontal way. I want to see them into a vertical list. So I can use ls dash l. So dash l is the option that means show me the long form, or I can use ls dash la. So not only long form, but show me all files, even if they are hidden files. Show me those as well. So you can see options can modify the way output is shown. And some commands can also take the argument, like I want to list only the content of a particular folder or directory. I can then use ls-l and then the name of the directory or path to the directory. So the path to the directory will be the argument, so the object on which the command will act, right? What about GUI? So GUI, as we already talked about, that it's the desktop environment, and it consumes the issue with GUI is that it consumes significant hardware resources, right? Specifically memory and processor time. So on a server, these resources can be used to the services that it is providing, right? Like a database server or a file server. So this should be dedicated to the services, and that's why generally you don't even decide to use GUI on the server side. But if you're using on the client side, like desktop systems, they might need a user-friendly GUI, of course, so that you can install media codecs and use browser and everything. But servers usually do not need it, right? And the desktop environment is the GUI solution, as we have discussed, the genome or KDE and all these things that as I mentioned earlier, right? So that's it for today. I just wanted to introduce you guys the basics of this course, what exactly will be covered, and also the basics of Linux. So I'm going to send you the PPT that I use for this session, as well as the PDF with the recommendation for which OS you should install. So you will have this week to install everything. And I have sent you the VMware download link as well, right? So you can actually set it up everything from there. Feel free to get in touch with me through the Facebook group or under the comment section of the recordings, and I will be answering you as soon as possible. Don't send directly the email for that, because generally the email is not checked so often as I check the Facebook group or the comments that come on the record. So that will be a better way to ask around, right?
I have a question.
So thanks, guys. I'll see you next week. Any other questions? Let me know.
Yes,
Okay, thank you.
I have a
Thanks, Todd.
question.
Yeah, Micah, tell me.
Do you have to memorize the command line or you don't?
Sorry, I couldn't hear you clearly.
I said, do you have to memorize the command line or you don't have to memorize the command line?
Oh, that's actually a very good question. So the answer to this question is that nobody actually remembers all the commands, right? Because operating system is huge and there are so many commands. So your objective is to understand what does the command do, but then exact all the options and the structure you don't need to remember, because we will see the tools so that in case if you forget the structure or if you forget some important option, people forget all the time. So there are helps that we can take within the CLI to complete the task. So don't worry, you are not expected to remember all the commands. But what is important is to understand the overall idea. Like if I say, okay, cat command actually shows the content of a file, or ls command lists the content of the file. So when you remember just the high level information, that is more than enough.
Okay. Thank you.
Yeah, of course, we are going to do the practice also. So you will see that it becomes more and more comfortable, especially for the basic commands. You will start remembering them as well. But again, we will see the helps that we can take directly from the Linux operating system to see all the options that we can use.
Thank you.
Thanks, Michael.
All right.
All right, guys. So have a good night. I'll see you next week, and I'll send you the PPT and the PDF that I use in this class.
All right.
Okay.
Thank you.
Thank you. Good night.
Good night. Bye bye.